Welcome to Vibratech Trainers and Consultant Private Limited. We are going to see an interesting case study on compressor. This is applicable for all types of industrial compressor. Case study prepared by Vijaya Krishnan Venugopal, Director of Vibratech Trainers and Consultants Private Limited, Chennai. He is a chartered engineer with more than 35 years of experience. He is an international vibration consultant and ISO certified vibration analyst Cat 3 certificate holder. Also, he is certified maintenance and reliability professional from SMRP. The compressor we are going to see are coupled directly with motor of capacity 1250 kW and running at 1488 RPM. Compressor is mounted on a steel frame, on concrete floor, at ground level, with anti-vibration mounting. Vibration measurements are taken in all three directions: horizontal, vertical, axial. In each location, measurement locations are motor and EE bearing, motor D bearing, compressor male rotor D bearing, compressor male rotor and EE bearing, compressor female rotor D bearing, compressor female rotor and EE bearing. Vibration amplitudes are collected in terms of displacement in microns peak to peak, velocity in millimeters per second peak. And now on to the vibration limits. As per ISO standard, and with our previous experience, when the velocity falls below 10.0 mm per second peak, it's considered as good. When the velocity falls between 10.0 to 18.0 mm per second peak, it is considered as fair. When the velocity falls above 18.0 mm per second peak, the equipment is considered to be rough. As the initial steps of analysis, the vibration values are maximum at motor drive and axle, velocity up to 18.2 mm per second peak, and displacement of 42 microns peak to peak. And at air compressor, maximum velocity is at driven shaft NDE axle, with 22.8 mm per second peak point and displacement of 75 microns peak to peak. And the equipment falls under rough category. The highest amplitude spectrum of air compressor are shown. The spectrum at motor drive shows some bearing inaccuracies and transmission of vibration from compressor to motor due to meshing inaccuracies between its internals. The spectrum at compressor shows the frequencies of meshing inaccuracies between its internals and axle play and improper fit in bearings. Also, abnormal noise during loading time of compressor was physically observed. Based on analysis, following suggested actions are to be taken. Inspect compressor internals for wear, scoring marks causing float excited frequencies. Inspect compressor bearings for axle play and improper fit between bearing with its housing, and if it is required, replace the same. Inspect suction and delivery air filters for choking damage causing abnormal noise during loading of compressor. Carry out inspection rectification for trouble-free operations. Vibratech cater among all major industrial sectors. We conduct vibration analysis level 1 and 2 training programs online and also in plant. ISO certified vibration analyst category 1, category 2, category 3 training and examination. Services we provide are vibration analysis, in situ dynamic balancing, laser alignment, motor current signature analysis, thermography, building or ground vibration measurements. We also market and provide service for machinery vibration analyzers and meters, and low frequency building vibration analyzers.